Hello everyone, welcome to another video. In this video we are going to see how we can put in practice the hexagonal architecture with .NET. Okay. In my previous video about this subject, I explained and gave an introduction to hexagonal architecture. So if you haven't watched it, please do, because that will serve as the basics for this video. Okay, so what are we going to achieve here? What we want to do is to have this architecture in .NET. It's not going to be as complex as this one. I'll just simulate a workflow of someone that wants to compute a tax rate for a given continent, so that we see a flow of an actor, which in our case it's going to be us using Swagger, but could be very well be a front end, calling an endpoint to compute a tax rate for a continent, and then seeing our business logic executing, and then this business logic calling external actors or driven actors, okay? Like database and then a notification system. Even though I must say that we are not going to actually use any real driven actors. So we are not going to actually use RabbitMQ or a database like MongoDB. In the case of MongoDB, we are going to use an in-memory collection just for simplicity's sakes, okay? So I already have the code prepared, so let me just show you how this will look like, and then we would go step by step into understanding the different layers, okay? So first things first, it's important just as an highlight to understand that tests, they have I would say an important role or a highlight role in the hexagonal architecture, because on the original description of the pattern or architecture, Alistair Coburn says that hexagonal architecture also allows tests to equally drive the application, like normal users, let's say. So by having tests in place, you allow yourself to check if your application can actually run regardless of the calling actors, let's say, the driving actors or driver actors, okay? Because that's the point of the architecture, is to avoid abstractions into our business logic and allow the application to be equally driven by tests, command line interfaces, or actually user front ends or other systems, okay? So tests, they have this interesting role, and they allow you to check if you, even on your ports, if you can plug and play different things there, so that effectively you've achieved the purpose of hexagonal architecture. But I diverge, let's go into the architecture itself, okay? So I'll start first with what I call core, and this is the hexagon, okay? This is where we will implement our use cases, our business logic, and so on, okay? So the first thing that I want you to know is that I created a use cases folder, and by the way, if there's something that hexagonal architecture is not, is prescriptive, okay? It does not tell you how you should structure your code, okay? Anything that I tell you and show you here, it's my own interpretation of the pattern and its nuances, okay? It's not as prescriptive as other architectures like clean architecture and so on, okay? So that out of the way, let's continue. In my use cases folder, I have this tax rate folder, which is, if you will, we start to go deeper into the domain, and this is like a grouping of use cases. So use cases that relate to tax rate, okay? And inside of it, you will see a domain folder where I put the exceptions, the models, and so on. Okay, so if you see here, I have my exceptions, my domain exceptions, and I also have models. In this case, I have a tax rate model that has some behavior attached to it. It's very simple for now. And as I told you, inside this tax rate folder, there's like a group for use cases that are related to tax rate. I have my compute tax rate use case, okay, which is what we are interested now in testing. Okay, so inside this compute tax rate folder, which, as I told you, has a specific use case, just have one use case. Okay, I have the port definition itself. Okay, I define what is the contract that should be applied when you consume this use case. Okay, now I've been speaking about use cases and implementing use cases. Okay, and before we go into the actual implementation of the use case itself, let's first understand the anatomy of a use case. Okay, what a use case is. Okay, so a use case is just an intention that something has when it interacts with your system. That can be executing a command, a query, sending notifications, whatsoever. It does not matter. Okay, but someone, when they interact with your system, they have a purpose, and this is the use case. This is the intention that they have when they interact with your system. Okay. Now, in my perspective, there are three ways, or three intentions, if you will, groups of intention that we could have when we interact with a system. Okay, we have the normal use case, okay, which is I interact with a system, I provide a specific instruction, and I'm expecting some data back. Okay, so this is what I call the normal use case. Okay, I call it I use case. Okay, it has an input and an output. Okay, I also have cases where I just want to provide a command, okay, an execution, and I don't care about the outcome. I don't care about the result. In this case, I call this unit use case. Okay, some people use this term. I like this term. Okay, a unit use case is a use case where you only have an input and there's no output. You can almost draw a parallel here between this unit use case with the commands in CQRS, where you just provide an instruction and you don't care much about the return of that command, because you're just your purpose with a command is just to execute some business logic. You don't really normally care about the result. And on the other way around, we have what we call nullary use case or nullary use case. And this is a use case where you don't have any inputs, but you just want to execute something that just returns a result. And this is a notation that, or a name, nullary, that some people use for this use case. I also particularly enjoy this naming convention. And if you will, you can draw a parallel between this use case and the queries from CQRS if those queries did not have any filter parameters, okay? For example, a get all continents or whatever, okay? And you can even just have this as the base use case and have variations of this and implement a unit use case and a nullary use case based on this one. But for simplicity's sakes, I just want to have three separate just to showcase you what they are. Okay. In our case, we want to execute a command, and have some result back from it. Okay. So coming back to the use case, they follow, and just as an important mentioning here, they follow the command pattern. Okay, I highly advise you to have a look at what it is, the command pattern. But pretty much with the command pattern, you wrap some execution, some intent into an object. And then technically this execute method should have everything it needs from this execute command, configurations and so on, to properly execute the work. Okay, but I highly advise you to look for a more in-depth explanation on, and perhaps clearer explanation of what is the command pattern. But this is the pattern that I personally like as far as use cases go, because use cases, they should only execute something, and that something can be this execute action here. Okay, but coming back to the anatomy of the use case here, I could have just used this in my use case definition here, or in this case implementation, but I like to have a specific interface just to wrap this this use case definition, so that it's a bit more transparent for the user or for the consumers of this. They don't have to know exactly the details of how to set up the use case. In this case, I just create an iCompute tax rate use case, okay? And this is a I use case, so the normal use case that has a continent as an input and returns a double, okay? So this is the use case definition. So where do I keep this definition? Well, on the core project, in the use case folder, I created a common folder, and inside a ports folder that I created this use case definition class where we have all the use cases defined. Okay. So coming back to the actual use case specification. So as I told you, inside the use case folder, and this is, keep in mind, the specific use case, I defined the port that will be used to invoke this use case, and I defined the use case implementation itself. Okay. In this case, this use case needs to go to the database to retrieve a tax rate object, and then it's, as I showed you, we have custom domain exceptions. So in this case, it will throw an exception if I cannot find a tax rate for that continent. Then I compute the tax rate, and then I send a notification. Okay. So if you remembered from the diagram we just spoke, so I define this tax rate port here. It will be used from the outside. We will see that in a second, but I executed some business logic here. But for that, I had to go to the database, retrieve some information from the database, and then after I execute the business logic, I send a notification, okay? Now, I did not show you where these ports are defined, so let's go back. So since I expect the database interactions and notification interactions to be something that multiple use cases enable, inside the common folder where I have the use case definition, I have also the ports grouped by intention. Okay, and this is something that the author, Alistair Coburn, sometimes mentions, is that we can group ports by their intention. Okay, and then I have a port that is for notification. Okay, I have just an iNotification with a notify async method. And I have a port for persistence, so the port that will interact with my database. Okay, a simple I repository here. It doesn't have much methods, just has the method I need for this specific use case, but you can of course extend it. Okay. If you want to have multiple things behind this notification, for example, I want to have an email notification and whatever, this would have to be inside a factory. You have to pass in the notification type and then return the appropriate I notification. You will return an I notification back, and then of course you would have the multiple implementations of these notifications. Okay, but we are not going to do that right now. Okay. So the use case, so we have here the ports defined. Okay, we inject the ports that we need. In this case, these are driven ports, so ports that our use case uses, enables. Okay, I have the repository port, so a port to get the state and then a port to notify. And if we go back to the diagram again, this is what we have. Okay, we specify the port, we have our business logic. That business logic needs to go to the outside world to perform some operation, and we have to specify the ports for it to do so. Keep in mind, even though on this diagram the ports are designed in the outside, ports are actually inside the hexagon. So the hexagon defines, so inside my core, I define the ports I need. Okay, and then we will soon see who implements the ports, but it is the core project, the hexagon, that defines the ports. Okay, and so yeah, so this is a bit of how I would structure the core. So our business logic. Let me close all tabs. So, and go back to the diagram. So we defined everything here. Okay, we defined the models, the use case, the ports, the driving ports or driver ports, and the driven ports. And now we need to think, okay, first I need someone to interact with my application. Okay. And secondly, I need to grab data from the outside world and send notifications. So I need something to implement my ports. So let me start with the last one that I just mentioned, the ports that implement the driven ports. Okay. And so I have two. So in the I created an adapters folder where I have all of my adapters. I separate them by their intention. So I have here driver ports, so ports on the left side, or in this case adapters, sorry, adapters on the left side of the hexagon. And I have the driven ports, so ports on the right side of the hexagon, meaning ports, or in this case adapters that our application would in runtime interact with. Okay, it doesn't actually interact with them, but the interaction is done via the ports. So on the driven side, I have an adapter for MongoDB and RabbitMQ. Okay, they are simple class libraries. Okay, and if I show you the diagram again, this is the thing I'm just mentioning. Okay, we already defined the ports on the hexagon previously, and now I need to implement the adapters. Okay, those adapters, they implement the ports. Okay, so that they act as an interface with the driven actors. Okay, so in my case, as I told you, I didn't actually use MongoDB itself with Mongo context and so on, and RabbitMQ the same. In the case of MongoDB, I created a project for each adapter. Okay, before I go on, I like this approach. I think it keeps things separated, because these adapters, they tend to grow as time goes by, and so having a project for each one allows you to keep with that isolation. Okay, that's just a personal preference. You can also do this by folders. Okay, but I created a project for the MongoDB adapter, and as I told you, I just have an in-memory collection, just a simple data structure here that would simulate whatever we had in Mongo. Okay, and I have here an instruction. Of course we would inject the MongoDB context or something like that here. Okay, As I told you, the adapter, it has to implement the port. Okay, this iRepository is the port that is defined in the hexagon in what we call the core. Okay, and then I have just a simple method here that would be called when our application actually retrieves things from the database. Okay, and the same token, I also have a very simple implementation here of what could be a notification from RabbitMQ. In this case, we just write to the console, but you can imagine that we would inject here the RabbitMQ client and all the connection factories and do whatever we want with them. Okay, but for simplicity's sake, I just write to the console. Okay, so these are my adapters. Okay, on the right hand side of the hexagon, so the driven adapter, so adapters that interface with actual objects that our application would speak with, databases or message queues and whatnot. Okay, so if you go back to the diagram, we already did all of this part, or talked about all of this part, but we haven't yet spoke about the left side. Okay, so the usage of our business logic. Okay, so in the same adapters folder, I have an adapter for driver or driving, whatever name you would like to call this, which represents the left hand side of the hexagon. Okay, and so in this case, I created a web API project that has a simple endpoint. Okay, and our endpoint is this one. Okay, so this endpoint will represent or will implement this adapter, if you will. So the entire project itself is the adapter, but the endpoints themselves are this adaptation layer, if you will. So here are the adapters, and then either via Swagger or via front end, you would call this adapter here. Now, one interesting thing that you can see here is the following. You can see the adaptation happening. So we, from the endpoint's perspective, we receive a string, okay, as an input, let's say. But our use case, when it executes, it expects this enum, this continent enum. Okay. So on this adapter, we convert the outside world's language, which is a string. We convert this outside world language to a language that our use case understands. In this case, an enum. Okay. So you can see this adaptation. Okay. In this case, this is an input adaptation, but if let's say that this execute async returns a double, but I want to actually return an integer to the front end, then I would have to do a ceiling, for example, on this double or whatever operation you want to do. Okay. You can also adapt the output that you get from the use case, not just the input. Okay. And we will see this in action, but before we see this in action, you might have seen that I have this weird stuff here, okay? This very weird stuff here. Not your typical program CS file. So let's assume, and let me go back to the to this diagram. Let's assume that no, I just told you that this is an API adapter, this is a web API, and then these two are class libraries that I just implemented, and this is also a class library. But .NET itself, in .NET itself, we need to do dependency injection amongst many things, right? So I have this port here, and I have its concrete implementation, and so this is valid for the right hand side, but also here. Okay, I have the use case port definition, but also I have the use case itself here that implements this port. But somehow in the runtime, we need to do dependency injection so that when someone requests an iComputeTextRate use case interface, they get a concrete implementation. So normally what we do is, because this is a web API project and has this the dependency injection container and so on, we normally do a reference between this project and this project. Okay, I put this as a red, and we do a reference from this project to this project, and we do dependency injection. Okay, but what's the issue with this? The issue with this approach is that I don't want to have my adapter or one adapter knowing specific implementation details of other adapters. Adapters, they should be isolated. They should not know anything about each other, because if they know about each other, you know what could happen in the code? We could directly here on the API call the specific implementation. Okay, a specific implementation of another adapter without even going through the use case. So we want to prevent adapters from knowing about each other. They don't need to know about each other. Okay, but that raises a question. So how can I, while maintaining this web API project to serve HTTP requests, how can I do dependency injection? Okay, and there's a very well-known pattern for that called the composite root pattern. This is a pattern where you have a project, another project, and that project is responsible for all the instantiations. Okay, that project knows all the projects and does this dependency injection stuff, or at least it aids in this dependency injection, so that ultimately at the end of the day, no adapter needs to know about each other. Okay, and how can we implement this composite root pattern with .NET specifically? Okay, a couple of things. First, we can disable our API adapter to prevent it from having this the behavior I just told you with doing this dependency injection and so on. We use this output type as library. Okay, and by doing this, you can see our program CS needs to suffer some adjustments. Namely, we cannot have this program main CS file as usually we have. We have to find a way to allow from the outside world the execution of this web API project. And how we do that? Well, we can just have in the constructor of the class, we can pass the arguments like you would, for example, in the program CS. And we also pass in from the outside these options actions, which allow you to do the dependency injection from the outside world without you knowing that the other adapters exist. Okay, so yeah, how do we do this ultimately? Well, we need, as I told you, to have another project. We can call it host project. This project knows about every other project. Okay, this is a nasty project. It knows about everything. It's coupled to everything, which is fine as long as we keep the rest isolated and independent. Okay, so this finance, I called it finance host. You can call it whatever you want. This is the composite root. And inside of this project, this is where we are going to actually do the wiring between every project without coupling them, without them having to know about each other. So if you look at the program CS of the API adapter, as I told you, you saw here that we passed an action, and that action has configured, or will be configured, or we will configure in it the dependency injection, okay? Now, if you look at the program CS of the composite root itself, you see that we pass in arguments here, and we also pass in the configuration of the dependency injection so that the API project itself does not need to know about the MongoDB adapter or the RabbitMQ notification adapter. Okay. Of course, you can even split this more. You can have just a method to configure the adapter and then a method to run the adapter. I just placed everything in the constructor for simplicity's sake. Okay. But by just running this new here, you will execute the web API. The only thing is that you don't actually configure the dependency injection here for those small details. You have it from the outside world. Okay. But other than that, on the web API itself, the API adapter, you have here the or you should have here normal dependency injections for the use case and so on. Okay. So let's see this in action. But before we do, again, I have an extension for ReSharper where I can see the dependency diagram of the projects. Okay. So, and this is just to show you that this is how this looks like when we have this composite root. Okay, all the adapters, so here you see the adapters, here you see the hexagon, all the adapters, they do not know about each other. If I didn't have this composite root here, the API adapter that in itself has dependency injection capabilities, it would have to have a reference to this adapter, and it would have to have a reference to this adapter so that we do the dependency injection. But that's not needed with the composite root one. Okay, and of course, sorry, you could see here on the diagram I was showing you that the core, so the hexagon was at the center of everything. Okay, so the hexagon, the core, is at the center of everything. Okay, and this is normally what you should expect in domain-centric architectures. Okay, where we give a highlight to the domain. Okay, in this case, in hexagonal architecture, we don't have this nomenclature, but the intention of having the business logic isolated is there. Okay. So yeah, so this is how the diagram looks like after you do all of this rework and you guarantee the isolation between the adapters. Okay. So let's actually now execute it. Let me put a breakpoint just for us to show things running. So I'll put a breakpoint on my on the endpoint. I will put another one here, and then we can also put a breakpoint on the driven adapter so that we see indeed that the dependency injection is properly working. Okay, put here another breakpoint here. Okay, now let's run this. And so just to remind you what we expect this to happen. So we are calling the adapter from, let me show you here, sorry. Okay, so we are calling the adapter from the outside world. Okay, We are going to use Swagger in this case. It will call the adapter, and then that adapter, which we have a breakpoint, will call the port, and then that port is wired up by dependency injection with some concrete implementation inside core. And then this business logic, our core, has connections to the outside world via ports. So it doesn't directly call the adapters, and then via some wiring in dependency injection, it gets mapped to some specific adapters. And those adapters, they are the ones that connect with the outside world, okay? Now, let's do this. I will call this endpoint. Let me put here Africa as an example. And if I show you the breakpoint, you will see that we hit the adapter. Okay, we hit the adapter here. We do some adaptation, so we convert the language of the outside world to something that the use case itself understands, so to an enum. And then if we click on this, this will go to our use case implementation. And then we've wired all of this with dependency injection. So when I go to the repository, I'm actually going to the adapter itself, the Mongo adapter that I've configured. And this will output some things to the console. You cannot see the console, but it's here. Okay, so it's outputting things to the console. And then it's not null because we have data, so it will skip this validation, and this is a domain object, and so it will call the business logic here. It has a specific tax rate, and now we will send a notification. This will go through again the port, but the port is wired up with some concrete implementation, in this case a RabbitMQ1, and then this will send a notification. Of course, for now we are just logging into the console. What would be the contract we would send to the outside world, and then we just finish the execution, and then that's it. So we get a response back. Okay. So hopefully it was clear to you what what was at stake here, as far as this execution goes, hexagonal architecture goes. So we were able to see all of this end-to-end flow from a driver actor's perspective, and we saw some isolation, how to do the isolation in the hexagon itself, and how to wire things up so that the adapters, they don't know about each other, and keeping this isolation even further. Okay. Well, that's all I have to say in this video. Hopefully you've enjoyed it. Thank you so much for watching, and I'll see you in the next one. Bye.